Welcome to the Quiet Corner podcast. I'm Mira.
And I'm Evan. And today we are exploring a really unusual visitor to our solar system, an interstellar object known as 3I Atlas.
Yeah, its arrival sparked a ton of excitement among astronomers, raised so many questions, and it even inspired a whole community of remote viewers to try and probe its mysteries.
It's this amazing blend, isn't it? Observational science, analytical curiosity, and then this very human search for meaning when the universe just throws something at us that does not fit in the box.
It really is. So let's set the scene. 3I Atlas was detected by the Atlas survey on July 1st, 2025. And right away, it was a huge deal. It was only the third confirmed interstellar object we'd ever seen entering our solar system.
Before we dive into Atlas, maybe we should quickly recap the first two. They were pretty weird in their own right, weren't they?
Totally. The first was Oumuamua in 2017. It was bizarre. It was highly elongated like a cigar or a pancake, and it had the same kind of non-gravitational acceleration we saw with Atlas, but with no visible outgassing or comet tail. That's what really got the speculation started. Not at all. And from the very start, scientists knew this thing was different. It wasn't behaving like a textbook comet.
How so? What was off about it?
Well, its motion. It showed this subtle but persistent acceleration that gravity alone just couldn't fully account for.
Okay, but regular comets do that, right? The ice on them heats up, sublimates, and creates these jets that act like little rocket thrusters. It's called outgassing.
Exactly, they do. But with this object, the acceleration was unusually steady. And at times it was like directionally inconsistent with how we know comet activity works. It just didn't add up.
Inconsistent. All right, so that's the first major red flag.
Oh, it gets weirder. Researchers also noted it had a pronounced sunward and-time tail.
Wait, an anti-tail? So a tail of dust pointing towards the sun instead of away from it?
Yeah, I know, it's completely backwards. On top of that, some measurements suggested it had unusually high levels of metals, like iron and nickel, in the material it was ejecting.
Okay, so weird acceleration, a backwards tail, and it's shedding metal? This is not your average cosmic snowball.
Not even close. They also reported its coloration was deeply red in several observations. And this other property, unusually strong negative polarization, further highlighted just how different this thing was from any comet in our own solar system's catalog.
So every piece of data they got just made it more of a puzzle.
Pretty much. Then the radio telescopes added another layer of intrigue. South Africa's Meerkat radio array detected these narrow hydroxyl absorption lines.
Right, and hydroxyl is the classic chemical signature for water, so that suggests it did have volatile materials, like a comet should.
It did, but the context and the characteristics of the signal itself just prompted this huge debate. Some researchers argued for a standard, if unusual, comet interpretation, but others insisted that the sheer consistency of the signal, plus the object's weird geometry, demanded a much deeper analysis.
So even the data that seemed to fit the comet model didn't quite fit, and all of these scientific puzzles created the perfect fertile ground for some more outside-the-box thinking.
Which brings us to Avi Loeb. He's a Harvard astrophysicist who is pretty well known for advocating for, let's say, non-traditional hypotheses.
That's all way to put it. He's not afraid to say the A word.
He isn't. He publicly commented that the possibility of an artificial origin shouldn't be dismissed prematurely.
And he had a specific reason too, right? Something about when it passed behind the sun.
Yes, he argued that period would have been the optimal moment for a maneuver based on the Oberth effect.
Ah, the Oberth effect. For our listeners, that's a real engineering principle. It's how spacecraft maximize their propulsion. Basically, you get the biggest bang for your buck if you fire your engines when you're moving fastest, deep in a gravity well.
So, Loeb estimated a meaningful, though not definitive, probability that the object could be engineered, and his comments, as you can imagine, fueled both excitement and skepticism.
I bet. Some were probably praising the intellectual openness, while others were cautioning against speculation not grounded in, well, in extraordinary evidence.
Exactly. And while the astronomers were continuing to gather data and debate, a whole separate community turned its attention to Three Eye Atlas.
The remote viewers.
Right. Now, for anyone who doesn't know, remote viewing is a practice that was actually developed during the Cold War. Trained individuals attempt to describe distant or hidden targets using just their intuitive impressions.
This was the Stargate project, right? The U.S. government actually funded this for years before it was declassified in the 90s.
That's the one. And look, the method remains extremely controversial. Some controlled studies have produced statistically intriguing results, but others have failed to replicate them reliably.
Yeah, it's definitely not what you'd call hard science, but it's maintained this very dedicated following, and people continue to use it in these kinds of exploratory contexts.
Which is exactly what happened here. Remote viewers approached Three Eye Atlas using blind protocols.
And that's key. Blind protocols mean the viewers weren't told what the target was. They're just given a target number or a coordinate, so there's no bias going in.
Right. So several independent groups conducted sessions. Some of the most widely discussed ones came from the Farsight Institute. And the viewers there, they described impressions of structure, complexity, and geometry that seemed, well, more like engineered objects than natural rock or ice.
What kind of things specifically?
Some perceived internal cavities or frameworks. Others reported the presence of smaller associated objects, almost like escorts or components.
Wow. And were these motifs consistent?
That's the most interesting part. Independent remote viewers, people outside of Farsight, also reported similar motifs, suggestions of internal structure or some kind of non-natural organization.
Okay, but it is absolutely essential to treat this stuff with caution. Remote viewing data is not objective measurement. It's subjective impressions translated into sketches and language.
100%. Interpretation plays a huge role, and it's totally possible for bias to shape the final narrative. Still, many people found the convergence of these themes across different blind viewers to be noteworthy.
Especially when the hard scientific data was already pointing to an object that was, unlike most comets we know. It sort of aligns with the existing anomaly.
Exactly. And this whole situation just brings us to that broader question. What counts as evidence? In science, extraordinary claims require extraordinary evidence, and most astronomers would emphasize that unusual behavior doesn't automatically imply an artificial origin.
Of course, and it's the most likely explanation, really. Interstellar objects form in different environments, under different stellar conditions. Three Eye Atlas may simply represent a class of object we've just never seen before.
Right. The hydroxyl lines, the weird acceleration, the red color, the metals. All of it could have perfectly natural explanations, even if we're still working to refine them.
Yet the story itself highlights how these different ways of understanding the world can intersect. You have instrumental science giving us measurements, spectra, orbital calculations.
And intuitive methods like remote viewing giving us subjective impressions. And public imagination just fills in the gaps. All these layers shape how society responds to an anomaly like this.
So looking ahead, what's the scientific consensus on what to do next?
Well, researchers agree on a few priorities. First, and this is the big one, expand full sky monitoring programs and improve early detection of interstellar objects.
Which makes sense. Better detection gives us more lead time, which means we can get better observations, especially around key moments like when it passes the sun.
Exactly. Second, they're encouraging coordinated campaigns. Using optical telescopes, infrared instruments, radio arrays like Meerkat, and space-based observatories all at once. Only a multi-instrument, multi-wavelength approach can give us the clarity to classify future objects with confidence.
Culturally, though, Three-Eye Atlas is just this perfect reminder of how we respond when we're confronted with the truly unknown.
It really is. Whether the object ultimately proves to be a rare type of natural body or something far more unusual, the debate itself reveals our collective desire to understand our place in a universe filled with mysteries.
And that's why we keep looking up.
That's it exactly. Well, that feels like a good place to wrap for today. Thank you for listening to the Quiet Corner podcast. If you enjoyed this episode, consider following and sharing it with others who enjoy deep dives into science, anomalies, and unexplained phenomena.
Until next time, stay curious, stay thoughtful.
And keep looking up